Right, question 1.2, and I'll just write 1.2.1 there. Express each number below as a product of its prime factors in exponential form. Now, this sentence has been a problem for most of you because of the language. You don't understand the language, so you know how to do this, but if you read it in that way, a lot of you did not know what to do because you don't know what it means to express. You don't know what it means. We don't know what product of its prime factors mean, and then of course exponential form. So there's a lot of language being used here, and it's about understanding what's being asked of you and then executing or applying. So this basically speaks of prime factorization. In other words, taking a composite number like 198 here and 3960, taking those numbers and breaking them up into a product of their prime factors. And of course that means we need to use the ladder method, and that's the obviously the preferred or conventional method that we have been using in class. It's the ladder method. So I'm just going to make some more space here. And so in order to answer this question, we're basically going to take 198. So for 1.2.1, 198 is the number that we will put into our ladder or onto our ladder. Just do that. And the process is as follows. What number, or what is the smallest prime number that can divide into 198? And of course, with even numbers, it would be 2. So the smallest prime that can go in there is 2. Okay, so 198 divided by 2 gives us 99. So that would be 99. And I write it on the left-hand side. So now I ask myself, what is the smallest prime number that can divide into 99? And again, after a while, you become acquainted with these calculations and questions, and you of course would know that 3 is the smallest prime number that can go into 99. So that would be written on that side. So 99 divided by 3 gives us 33. So that is 33. And again, the smallest prime number that can go into 33 is again 3. So 33 divided by 3 is 11. And again, the smallest prime number that can divide into 11 is of course 11 itself, because 11 is a prime number, and then that divided by itself is 1. And note that the 1 goes on the left hand side where all the other answers were, all the other answers. So basically in your ladder, on the left hand side of the ladder, you have all your composite numbers. If you haven't noticed, all your composite numbers are on the left, and on the right hand side you've got all your prime numbers, or your prime factors in this case. So that's all your prime factors. So because 1 is not a prime number, you will not write 1 on the right hand side, it will go on the left, okay, with all the other numbers that are not prime. Of course 1 is also not a composite number, so it is on the side of the composite numbers, because that is the final answer that you would get when dividing the last two numbers there, and it will also just fall on the left. Okay, so that's just how the ladder is structured. So just note that 1 is not a composite number. All right, so what do I do after this? Well, the question asked to express the number, which number, 198, as a product of its prime factors. So that means after I've done that on the ladder, I will then say, okay, that means that 198 is equal to the product of 2 and 3 and 3 and 11. So 2 times 3 times 3 times 11. In other words, those numbers that are on the ladder over there. And of course, again, going back to the instruction, it asks us to do this in exponential form. Okay, so in exponential form, I need to then go one step further and say, well, this is 2 times 3 to the power 2 times 11. And now I have answered question 1.2.1. And then, of course, we will do the same thing with 1.2.2.